Properties of inverses. Property number one, the inverse of A inverse is equal to A. II, the inverse of matrix product AB is equal to the product of B inverse by A inverse. All right. And of course, you have to remember that when you're multiplying matrices, the order matters, because the multiplication of matrices is generally not commutative. Property number three is very useful to what we're going to do next. If we multiply a matrix by its inverse, we're going to get the I matrix. So A inverse times A is equal to A times A inverse is equal to the I matrix. And that brings us to our next section. So in this section, we're looking at how do we use matrices to solve a system of linear equations. So here we have our three equations, equations 1, equation 2, equation 3. All right, those are our three equations. So the first thing we're going to do is that we're going to represent the information as a matrix equation of the form AX is equal to B. So A, in this form, AX is equal to B, A is the coefficient matrix. So we take the coefficients of X, Y, and Z and form a matrix out of them. And that matrix is called the coefficient matrix. So we have A, B, C, D, E, F, G, H, I times X, which is just a column matrix of X, Y, and Z. And that's equal to B, which again is another column matrix, J, K, and L. So how do we solve a matrix equation of this form? We have AX is equal to B. So what we're going to do is that the next thing we're going to do here at 3 is that we're going to multiply both sides by A inverse. So we're going to have A inverse, that's here, A inverse times A times X is equal to A inverse times B. I multiply both sides of the equation by A inverse. But as we learned previously, whenever you multiply a matrix by its inverse, you're going to get the I matrix. Now, multiplying by the I matrix is the equivalent of multiplying by 1. When you multiply a matrix by the I matrix, the matrix is unchanged. So I times X is equal to X. And so X, which is my unknown matrix, or the matrix, the elements of which I do not know, is equal to A inverse B. So to solve a matrix equation of this form, of the form AX is equal to B, what we do is that we write back X is the unknown, and multiply the right-hand side of the equation by A inverse. All right, so effectively bypassing these two steps. So we just go from here straight to this step. We write back X and we multiply the right-hand side of the equation by A inverse. All right, so let's have a look at example 39. Example 39, it says solve the simultaneous equations. So I'm going to start out by writing it as a matrix equation. So coefficient matrix. That's A multiplied by X. And this is equal to B, which is 4, 1, 3. So now we have a matrix equation of the form AX is equal to B. To solve a matrix equation of this form, I'm going to write back X and multiply the right-hand side by A inverse. All right. So the first thing we need to do is to find A inverse. A is the coefficient matrix, so we need to find the inverse of the coefficient matrix. All right, so to find the inverse, A inverse is equal to 1 over the determinant of A times adjoint A. Adjoint A is the transpose of the matrix of cofactors. So we need to find the cofactor of every element. So we can start out by doing that. All right, so I'm going to find the cofactor of all these elements. All right, so the cofactor of the first element, of the element which is the element in the first column, the first row. So that would be the cofactor of the 4, and that cofactor would be equal to the determinant of -1, 2, 2, 1, and this is equal to -1, -4, which is -5. Second element, first row, second column, the element which is the first row, second column, which is a 1. So this is the cofactor would be the ones if I block out here and here. All right, so that's 2, 3, 2, 1. So that's the determinant of 2, 3, 2, 1. 2 1s 2, minus 2 3s 6, minus 4. The third one, that would be the determinant of 2, 3, minus 1, 2. This is 2 2s 4, minus 3. This is 7. Second row, first element, first column. The cofactor element for that would be the determinant of 1 2 3 1. So the determinant there would be 1 minus 6, which is minus 5. So cofactor element for this is the determinant of 4, 3, 3, 1. This is 4 minus 9. This is minus 5. Four, 3, 1, 2. This is 8 minus 3. This is 5. 1 minus 1, 3, 2. And this would be determinant of 2 minus minus 3, which is also 5. All right, so cofactor element for that 2, block out this, block out that, and we're left with the determinant of 4, 2, 3, 2. So this determinant of 4, 2, 3, 2, 8 minus 6, this is 2. Last but not least, the cofactor element for that And so that's the determinant of 4, 2, 1 minus 1. The determinant of 4, 2, 1 minus 1. That becomes minus 4 minus 2, which is minus 6. The matrix of cofactor. Start from the up top. This would be, now we have to also take into consideration signs, positive, negative, positive, negative, positive, negative, and positive, negative, positive. All right, so positive minus 5 is minus 5. Minus 4 is plus 4. Positive 7 is 7. Minus 5 is 5. Plus minus 5 is minus 5. Minus 5 is minus positive 5 is minus 5. All right, and the last row now is positive 5 is 5, minus positive 2 is minus 2, and positive minus 6 is minus 6. So it's a matrix of cofactor. So A inverse is 1 over the determinant. A inverse is 1 over the determinant. So I did not find the determinant. So let's go for the determinant. We know what A inverse is already, so let's find the determinant of A. The determinant of A would be 4. The determinant of minus 1, 2, 2, 1, minus 1. The determinant of 2, 3, 2, 1, plus 3. The determinant of 2, 3, minus 1, 2. So this is 4 into minus 1 minus 4 minus 1 into 2 minus 6 plus 3 into 4 minus 3. All right, so answer here is 4 times minus 5 minus 1 times minus 4 plus 3 times 7, and that gives me a determinant of, that's minus 20 minus 20 plus 4 plus 21. This gives me a determinant of 5. All right, so now A inverse. Let's write A inverse. Minus 5, 4, 7. So A inverse is 1 over the determinant, which is 5, times now A adjoint, which is the transpose of the matrix of cofactor. It's the transpose of the matrix of cofactor. So therefore, I'm going to have what? My first column, minus 5, 4, 7, minus 5, 4, 7. All right, I know I have 5, 5, 5 here. Not so sure about the signs. right, so the last two fives are negative, 5, 2, 6. And 5, 2, 6. The 2 and the 6, they're negative. So that's A inverse. So therefore X, which is X, Y, and Z, X, Y, and Z is equal to A inverse 1 over 5 times B. All right, what was B again? And B is 4, 1, 3. 4, 1, 3. So let's go about it now. 1/5, row by column, minus 20. 4 times minus 5. 5 times 1 is 5. 5 times 3 is 15. That looks like a 0. Middle row, 4 times 4 is 16. Minus 5 times 1 is minus 5. Minus 2 times 3 is minus 6. Bottom row, 4 times 7 is 28. Minus 5 times 1 is minus 5. 3 times 6 is 18. All right, so we have 1 over 5. This is got 0 up top, 5 in the middle, and what, 5 here? Looks like a 5. Yep. So therefore, what we have is that X, Y, Z is equal to 1/5 times 0 is 0, 1/5 times 5 is 1, 1/5 times 5 is 1. So now we have X is equal to 0, Y is equal to 1, and Z is equal to 1. All right. All right, that looks like success. Let's see if we can do it again. All right, here we're asked to find, it says write this equation in the form AX is equal to B. Well, we can easily do that. A is the coefficient matrix, so we have 2, sorry, not 2, 1. Taking only the coefficients, 1, 2, 7, 1, 1, minus 4, 1, 3, 1. This is A times X, X, Y, and Z. And this is equal to B, which is 3, 6, 4. Then, so this is A, and now this is the form A, X is equal to B. A is the coefficient matrix. We're asked to find A inverse. To find A inverse, I have to first find, we're asked to find A inverse. And A inverse is equal to 1. So we're at B. A inverse is equal to 1 over the determinant of A times adjoint A. Now, adjoint A is the transpose of the matrix of cofactor. So we have to first determine the matrix of cofactor. So for every element, That's the first rule. Second rule. All right. Third rule. All right, so we need to find the cofactor element for the first element in the first row. All right, so to do that, I would cover, ignore all the elements, ignore all the elements in the row and column that that element is in, and find the determinant of the remaining elements. So this would be the determinant of 1 minus 4, 3, 1. This is 1 minus 12, that's 13. 1 minus 12, which is 13. All right, the cofactor for the second element in the first row. All right, so if I cover the top row and the middle column and find the determinant of whatever it means, that would be 2, 7, 3, 1. This is 2 minus 21. This is minus 19. Cofactor element for the third element in the first row would be the determinant of 2, 7, 1 minus 4 minus 8 minus 7 minus 15. Now second row, first element. So if I block off all the elements in the first column, middle row, and the middle row, I'm going to find the determinant of 1 minus 4, 1, 1. So here the determinant would be 1 minus 4, which would be 5. All right, second row, second element. So that would be block off all the elements in the middle column and the middle row, and it's the determinant of 1, 7, 1, 1. So this is the determinant of 1, 7, 1, 1, 1 minus 7, which is minus 6. Second row, third element. All right, if I block off all the elements here and here, that's 1, 1, 7 minus 4. So this is the determinant of 1, 1, 7 minus 4. All right, and this would be minus 4 minus 7, which is minus 11. All right, third row, first element. If I block off everything here, madness. Here and here, it's 1, 1, 1, 1, 1, 3. So this is the determinant of 1, 1, 1, 3. Double checking to confirm. All right, the determinant is 3 minus 1, which is 2. Third row, second element. If I block this and this, it's 1, 2, 1, 3. One, 2, 1, 3. So this is 3 minus 2, which is 1. Lastly, 1, 2, 1, 1. All right, 1, 2, 1, 1. Just double checking. All right, and this becomes 1 minus 2, which is minus 1. So let's write the matrix of cofactor. Remember the sign convention: positive, negative, positive, negative, positive, negative, positive, negative, positive. So positive 13 is 13. Negative 19 is 19. Minus 19 is 19. And positive minus 15 is minus 15. Negative positive 5 is minus 5. Positive negative 11 is negative 11. And negative positive, sorry, 5, 6. All right, slight error. So negative, then positive. Positive negative 6 is negative 6. And then negative 11 is positive 11. Third row, well, positive 2 is 2. Positive 1 is negative 1. And positive negative 1 is negative 1. So this is the matrix of cofactor. So now to get A, I need the determinant, and the determinant of A is equal to 1. The determinant of 1 minus 4, 3, 1 minus 1. The determinant minus 1, the determinant of 2, 7, 3, 1 plus 1, the determinant of 2, 7, 1 minus 4. All right, so this is 1 times 13 minus 1 times minus 19 plus 1 times minus 15. So the determinant here would be 13 plus 19 minus 15. The determinant here looks like it is 17. All right, so double check because it's so easy to make mistake with these things. All right, minus 1, 2, 7, 3, 1. That's good here. 1, 2, 7, 1 minus 1. Okay. Minus 8, minus 7, minus 15. That's good. 2 minus 19. Good. And 1. Good. All right. So 17 it is. So A inverse would be 1 over the determinant, which is 17th, times adjoint. All right, so the adjoint matrix is the transpose of the matrix of cofactor. So this is the matrix of cofactor. All right, and if we transpose it, we're going to get what? 13, 19 minus 15. minus 5, minus 6, 11, 2, minus 1, minus 1. And the solution for my equation, see if I have space around here. Yep, we do have some space. The solution of my equation is x, which is x, y, z, is equal to A inverse 1 over 17 and we have what? 13, 19 minus 15. Right? And everything you have to double check. You want to make sure you're not writing down something incorrectly. All right, minus 5, minus 6, 11, 2, minus 1, minus 1. All right, and this, you're going to multiply by b, and b is 3, 6, 4. 3, 6, 4. Let's go. So this is my 1 over 17. Row by column. 3 times 13 times 3 minus 5 times 6, 2 times 8. 13 times 3, that's 39. Minus 5 times 6 is minus 30. 2 times 4 is positive 8. Middle row, 3 times 19, that's 57. Minus 6 times 6 is minus 36. Minus 1 times 4 is minus 4. Bottom row, minus 15 times 3 is minus 45. 11 times 6 is 66. 1 times 4 is minus 1 times 4 is minus 4. 1, 17. So this is 39 minus 30 plus 8, that is 17. Then we have 57 minus 36 minus 4. We have 17 again. Then we have minus 45 plus 66 minus 4. And we have 17 again. So x, y, z would be equal to 1 over 17 times 17 is 1, 1, 1. So the solution for our system of equations is x is equal to 1, y is equal to 1, and z is equal to 1.